Right, so here's an illustration of the sorts of things that mathematicians are doing. There's two sets of whole numbers there, and the numbers on the left have a different property from the numbers on the right. Would anybody like to venture what they are? Anybody know? Okay, so let me tell you. You'll notice that all the numbers on the left are numbers that have factors. Okay, so 9 is 3 times 3, 6 is 3 times 2, 44 is 2 times 2 times 11, and this number has lots of factors including 2, but I don't know what they all are. These numbers are all prime numbers. Okay, and by prime numbers, you probably know what we mean by prime numbers, is it's a number that has no other factor. You can't divide anything into it except, well, obviously 1 and obviously itself, but there are no other factors. And mathematicians have been involved in trying to determine the properties of prime numbers, well, for many hundreds of years. And if you're a mathematician, something fantastic recently, and amazing and unexpected happened in prime numbers. And I'm going to tell you about that. Okay, so we all know about primes and numbers that aren't primes. Some people call non-primes composites. So every whole number is either a prime number or a composite number. And a natural question is, how many prime numbers are there? And one thing you will observe is that as numbers get larger, the gaps between the successive primes get larger. So a natural question is, well, do they ever stop? Do the gaps ever get so large that the prime numbers just stop and we run out of prime numbers and there is a largest prime number? Well, can I just ask, how many people would guess that the number of prime numbers is infinite and they never run out? Okay, so everybody is right, actually, because the ones that voted are right, and the ones that didn't vote, well, you knew they were infinite anyway. So the number of prime numbers is infinite, and they never finish or run out, and there's no largest one, and you can prove that they're infinite. And this is often, it's a question that kind of splits scientists and non-scientists, because people who aren't interested in engineering, computing, and maths will say things like, well, how can you ever prove there's an infinite number? If there's an infinite number, surely you can't find them all. There's too many, so how can you ever prove it? And how can you ever prove that there's an infinity of anything? Well, I understand that, but to prove there's an infinite number, well, we have a cunning plan called proof by contradiction, which is something that mathematicians and computer scientists and engineers often use. So here's just the proof. It's just one page. What you do is you say, suppose there is only a finite number of primes and they run out. Well, we can find them all. We'll list them all. And let's suppose it turns out that in total there are capital N primes. So suppose they're finite, and we'll call them P1, P for prime, P1, P2, P3, up to Pn. And that's all there are. Now I'm going to show that leads inevitably to a contradiction. So the easy way to do that, there are many ways of proving that the primes are infinite, but the easy way to do it is to say, okay, consider this number. If the prime numbers are finite, multiply them all together and add 1 and consider that number. Well, that number is either prime or it's not prime. If it's prime, well, it's obviously bigger than all of these because, you know, you multiply them all together and add 1. Big P must be bigger than all the P's. But we already said we had all the prime numbers, so here's an extra one. So that's a contradiction. So it can't be that these were all the prime numbers because here's a new prime that's bigger. What about if it's not prime? Well, big P is either prime or not prime. We've already found a contradiction if it is prime. If it's not prime, then it must have factors. And it must, in particular, have prime factors. So what are its prime factors? Well, I certainly can't divide any of these into it, because if I divide this number P by any of these P's, there's a remainder 1. So it can't have any of those as prime numbers, as factors. And so if it's composite, it must have a prime number factor that's bigger than all the ones that we already said we had. So that leads to a contradiction as well. And so that means there can't be, the only thing that can be wrong is our original statement, which is there's a finite number of primes. So there's an infinite number of primes. Now, some of you may have known that already. It was obvious from the show of hands that you did. So here's the big news in maths recently. So an amazing thing that's happened. If you list prime numbers, here's a couple of some pairs of prime numbers. You can see that there are lots that are 2 apart. So 3 and 5, 11 and 13, 71 and 73. They're all pairs of prime numbers that are 2 apart. And these are known as prime twins. And for 150 years, there's been an unsolved problem, what we call a conjecture in mathematics. Is the number of prime twins also infinite? And nobody has been able to answer this question. All the finest and most famous mathematicians in the world think that the number of prime twins is infinite, but nobody has been able to prove it. There's been absolutely no progress on this problem for a decade, and all the world's most famous mathematicians will tell you, or would have told you, there is no chance of this problem being solved soon. There's no chance of proving it soon. It's just too difficult. And one thing that mathematicians were working on, well, obviously, the question, is there an infinite number of prime twins? This is the same statement. There are an infinite number of primes at most n apart, where n is 2. That's the prime twin statement. Some mathematicians started working on actually what turned out to be a much harder problem. Is it true for different n? So are there an infinite number of primes 4 apart, or 6 apart, or 8 apart? Again, there's been no progress on this of any sort until in 2013, this guy Zhangs, who worked mainly at Subway and in a motel and had a part-time teaching job, the very small university, University of New Hampshire, small American university with no research capability at all, proved to the astonishment of the whole world of mathematics this theorem. There are an infinite number of primes, at most 70 million apart. Now, 70 million is not 2, right? To prove that there's an infinite number of twin primes, we'd have to reduce this 70 million to 2. And this came completely out of the blue. He was completely unknown. People didn't believe at first that he had proved it. I've looked at the proof. It's very complicated. It's 54 pages of very intense, complicated mathematics. I don't understand much of it. I understand the basic idea. It's very complicated. But when this first hit the press, it was posted on Archive web repository. An amazing thing happened, which was a worldwide internet project called Polymath 8 was set up to get all the mathematicians all around the world to all work together to try and reduce n to 2. And the first few reductions that were quickly made, 70 million was quickly reduced to 63,374,611. And then a day later, somebody reduced it to that. And then 12 hours later, somebody reduced it to that. And in the early stages of Polymath 8, just after Zhang proved his theorem, I talked to some fellow deans of mathematics. I used to be a dean of mathematics faculty, and they were having to close their buildings because people just went crazy, and there were groups of mathematicians locked in the maths building for days on end trying to prove this stuff. And some people just had to close the building and say, you people, you have to go home and wash and eat and stuff like that. But anyway, it just took the maths world by storm. Well, now, up till now, over 100 improvements have been made, and n currently stands at 246. So we've got all the way down from 70 million to 246. I believe the improvement to 250 was made by somebody from Oxford. Somebody has since improved on that improvement, 246. Will we ever get to n equals 2? Nobody knows. To me, this is just a beautiful and inspiring and unexpected story because A, it's global, B, it starts to answer one of the most long-standing and difficult problems in mathematics, And C, it was all started by a shaft of genius from a complete unknown that worked in Subway, essentially. Just amazing.